The data center industry is moving faster than ever, and behind the scenes, some seriously smart people are making it all happen. Welcome to the Inside Data Center podcast, where we dive into the stories, insights, and innovations driving real change across the industry. From hyperscale campuses to game-changing technologies, we're talking to the people shaping the future of digital infrastructure. Whether you live and breathe data centers or just want to understand what's powering our connected world, you're in the right place. Welcome to the Inside Data Center podcast. On this episode, I'm joined by Tim Heidel, CEO at Veir. We're going to be discussing the overarching power challenge faced by the sector and some of the solutions to manage this challenge, including a recent announcement by Veir and Tim himself. So, Tim, before we get into it, do you want to just give a quick introduction into who you are and your role at Veir?
Absolutely. Excited to be here. Looking forward to this conversation. Tim Heidel, CEO and one of the co-founders at Veir. This is a company that we started about 6 years ago now to solve the world's very hardest power delivery challenges. And of course, those challenges today exist largely inside of the data center sector. So this is an exciting moment for us as we navigate this industry.
Yeah, exactly. And we'll go into a bit more about power. Power is obviously a huge challenge for data centers, AI infrastructure, whatever you want to call it, but it's a huge challenge. I was reading today, and like I shared this morning, a 44 gigawatt shortfall in power for the US alone. So it gives you an idea of the challenge that we're facing in the coming years. Before we go into all of that, do you want to just give a quick insight into your career and how you sort of first got involved in the world of data centers?
Of course. So I'm an electrical engineer by training and started my career undergrad through PhD at MIT in electrical engineering, and then had the opportunity right as I was towards the end of my time at MIT to help lead MIT's Future of the Grid study that we published back in 2011. And that study really looked at some of the challenges facing the overall power sector over the next 25 or 30 years. From there, I went to ARPA-E with the Department of Energy and helped manage R&D projects across the entirety of the U.S., everything from two-person startups prior to being actually founding a company all the way up through the national labs and large companies and universities. Led a lot of their power electronics work and their power systems, transmission and distribution portfolio for about 5 years. And then ended up as a venture capital investor with Breakthrough Energy Ventures ultimately. And really enjoyed that role, enjoyed discovering a lot of different sectors. But then we started to do a lot of work in transmission, recognizing just how critical it is to expand overall power system capacity for a whole host of different reasons, right? Decarbonization, of course, being one, but of course now it's data centers at the absolute forefront of this. And so we started Veir focusing on transmission. And then a couple of years ago, a lot of the customers we were talking to really started to complain about challenges and bottlenecks they were facing at lower voltages inside the fence at data center campuses, and then even at low voltage inside of data center campuses, given the power demand increases we're seeing at the rack level as well as the AI pod level. And so it's been a fun journey to sort of now apply all that electrical engineering and power system and power delivery background into the data center field for the last couple of years.
Yeah, I was going to say that as well. Like, what we've seen a lot in the industry over the last, say, 2 years is people like yourself bringing that expertise from other industries into the data center sector. It was very siloed for a number of years, and it was difficult to get into this world. But now, because of the challenges, it's become really open to learning from that expertise from other industries and seeing how we can adapt that into the world of data centers.
Yeah, I think that's exactly right. There's a lot of parallels between the different industries. The data center industry, like the utility industry where I come from, builds very, very large scale critical infrastructure requiring the absolute highest levels of reliability and safety. And so a lot of the orientation to new technology and how you go about go to market strategies and adoption of new technology is actually very similar in the two sectors. Of course, there's also a sense of urgency and a demand for speed today that's unmatched in any other industry.
Yeah, and the speed only gets faster.
Exactly.
And from a power perspective, we all know that it's a huge challenge in the industry right now. And it is, I always say, it's the conversations I have in the boardroom, so to speak, with investors or CEOs, is people and power. It's always those kind of challenges that we're looking at and trying to solve. But how big, from your perspective, is this power challenge for the industry right now?
I mean, it's absolutely enormous. The numbers are almost unbelievable. And obviously there's a lot of different forecasts from lots of different agencies, but I think many of those forecasts indicate that, power demand from data centers is going to more than double by 2030. And this is also coming on the back of a long period in the electric power sector, at least in the US, where we didn't have a tremendous amount of growth. And so we haven't really been pushed to very quickly expand the system for some time. And so that even compounds this challenge even more, is now we have to go find ways to build generation, transmission, distribution systems even larger and faster, right? And of course, that same power problem that exists at the macro level also manifests down at the smaller level within the data center campus fence and inside the data center. And I mean, we're confronting challenges, as many of your listeners likely know, right? We've gone from a world where server X consumes somewhere on the order of maybe 10 to 20 kilowatts to now talking about megawatt plus racks in just a couple years, right? 2 orders of magnitude increase in anything, power demand or anything else over that period of time is just amazing.
Yeah, and I think, and your point around the power, the infrastructure, I guess it is a challenge you see in most geographies, isn't it? Where it's just not had to evolve that quickly, and it hasn't. And then you've got that balance between the demand is now as well as the forecast demand, isn't it? You've got that immediate demand, which is there, but you can't really adapt the infrastructure quickly enough to kind of manage with that demand. And that's where technological advancement comes in, isn't it? And you try and pick up solutions that can kind of cater for that immediate demand as well as help with the forecasted demand.
That's right. I mean, I think a lot of folks have really gravitated to finding specific locations so far where, for one reason or another, historically, there might have been a little bit of excess power or a large grid connection, right? Maybe there was a massive development for new manufacturing or some other industry that didn't quite move forward. And so you have the grid connection, you have land. Now it's an ideal spot for a data center. As the best spots and the best locations get oversubscribed, and as the low hanging fruit of power capacity start to get used up, you have to look for more innovative solutions that allow the system to grow a whole lot faster and easier. And so I think we're starting to see that level of desperation and innovation that forces in this industry when it comes to solving power problems.
Yeah, I always say that kind of a lot of innovation comes from necessity, doesn't it? It's that
exactly right.
Immediate need, that demand. We need a solution. Someone someone a lot more intelligent than me will come up with some solutions, and I think that's what we're starting to see in the market. And it brings us on, obviously, to Veir. Do you want to give us a quick outline of the organization, kind of what you do, how you do it, and then we can talk about the technology that you've recently announced?
Yeah. So as I mentioned at the outset, we exist with an aim to solve the world's very hardest power delivery challenges. And we do that using high temperature superconducting based power delivery solutions. So for those in the audience who may not be familiar with this technology, high temperature superconductors have been a new material that's been proposed for power delivery for several decades now, and it's been actively being developed. The other major use case other than power delivery is now in the fusion community, building these really, really large high field magnets that are required for fusion. And that's been actually driving a ton of the manufacturing scale in recent years. Superconductors are magical. Under certain operating conditions, you can actually push power through them concurrent without losses. And so you don't generate the I²R conduction losses that you would traditionally generate in copper or aluminum-based cables. And ultimately, the capacity of any cable is limited by the amount of heat that you generate and how fast you can move that heat away. And so using superconductors, we build cables that can achieve far higher current ratings and therefore transmit far higher power in a much smaller space. And this technology has been around for a while, and there have been a ton of really successful technical demos in the last 25 years, but it's never quite achieved the combination of economics, reliability, standardization of products, and scalability that is really required for ubiquitous adoption. That's our mission. So we are building very high current, compact, fast to deploy, efficient power delivery solutions. And we're actually addressing every power challenge that will exist behind the campus meter at this point. So inside the building, we're building low voltage power delivery solutions that can operate in AC or in the more modern 800 volt DC architectures everybody's focusing on today. And then outside the building on the campus, we can much more efficiently and much more easily move hundreds to thousands of megawatts around the campus using medium voltage cables up to about 35,000 volts.
Potentially quite a significant game changer based on what you've just said. And we're recording this on the 13th of November. And I believe yesterday, we were just chatting about it before we came online. Tim's been very busy the last 24 hours, so we're very, very lucky to have him. But yesterday, you kind of made the announcement regarding a recent demonstration, a demo, where you kind of outlined what this can achieve in the right environment.
Exactly right. So in industries where reliability and safety are really, really important, it's hard to convince folks that a technology is real without actually showing it physically. And so in order to show the industry that this is real and this is ready for scaling, we built this year a demonstration system where we built a 50-meter long cable and powered it to 3 megawatts in a loop in a simulated data center-like environment. And so now you can come out to our site, and we're encouraging folks to come out. We're really excited to throw the doors open and have folks tour this site and see 3 megawatts flowing through a very, very small, compact cable, illustrating what can be possible at the low voltage range, right? So I think what we've seen is as the server rack power consumption increases and the AI pod power consumption increases, the traditional power delivery solutions using copper and aluminum just simply become far too large, far too heavy, generate too much heat, and they're limited in how far you can transmit power inside the building because of the voltage drop you get with traditional conducting materials. They're also very slow to deploy, right? You need a lot of electricians, you need a lot of time to actually mount and build and deploy those solutions. We can cut the size and weight by 10 times. And that smaller form factor allows much more flexibility in how you can lay out your data center. It allows you to deploy a lot faster. It opens up space for cooling infrastructure. And so we're really excited about this. We call it our SL series, for low voltage series of products. That's what we demonstrated successfully yesterday. And I think it really is a key milestone point for the company to be able to now show folks hardware working at the megawatt scale.
Yeah, and what response have you had? I know I'm saying this and I'm thinking it's only been not even 24 hours or maybe just 24 hours, but I have to ask you, and I'm sure you've had conversations prior to the demo as well, but yeah, what response have you had from the industry or from people within the power space?
Yeah, so it's been great this year. I mean, we've spent a lot of time with customers of all shapes and sizes this year talking about this series of products and what we think we can do. And we're doing a lot of use cases with customers now to really understand exactly how would you deploy this in different contexts, in different architectural contexts. And I think there's been a tremendous amount of excitement. That excitement is growing. The urgency of the problem is absolutely here. But of course, it's a brand new technology nobody's seen before. And so there's always a healthy dose of skepticism around, will it work? Can you actually get it to do what you're claiming you can do? And so as we've gotten closer and closer to this, and we've started touring customers through the site and starting to really show a lot more data from the site, the response has been really incredible. I mean, I think it really is, oh, wow, this actually works. And folks can come into our facility now and say, I can start to imagine how this actually would look in my facility. And I can start to imagine, how do I get, eventually megawatts of power to a single rack? And that is the direction we're going. I think there's a lot of concern of how we get there, right? And I think all the interest in DC this year is certainly a huge step forward in the right direction, but it's not all the way there. And so I think a superconducting DC solution gives you an immense amount of flexibility. And so that's generated a ton of interest this year.
Yeah, I'm sure. And one of the other conversations I have quite a lot is about the ever-evolving designs, and data center design can change 10 times before it's even going to site, which is true for people that genuinely don't think it does happen. How can you integrate? I'm assuming you can integrate your technology into existing designs, but also future design or wherever the data center industry heads.
Yeah, exactly. So the full power and value of our solution is really realized when you leverage what we can achieve to lay out your facility or lay out your campus in new ways. Right. So the more compute you can get to a denser configuration, the more computing you can get under a single network switch, the faster you can ultimately achieve and the higher performance. So that's what we can do. But given that we have such a compact solution, given that we can carry power over such longer distances, we really allow folks to lay out their facilities in brand new ways. So that's how you get the maximum benefit. But along the way, there's also a lot of other deployment benefits and speed deployments that you can get, even if you're not necessarily going to immediately change the entire layout of your facility based around what we can offer. And so we can configure the solution for those conventional architectures. We can configure the solution for those future architectures. It's actually a really flexible platform. What we've demonstrated yesterday is a single cable carrying 3 megawatts at 480 volts AC. It turns out that same cable can carry far more power in a DC configuration. And we also have other designs that we can build that integrate multiple cables into a single pipe. And you can give you 6 megawatts or even 12 megawatts in a single deployed piece of infrastructure. So there's a lot of flexibility that we're offering folks.
And one of the big challenges with this industry, isn't it, is no one really knows what's coming. So when you're building or designing or configuring a data center, it's become very challenging because of what we talked about earlier, where rack density is increasing so quickly and technology is evolving faster than it ever has. So it is difficult to have that foresight and think, okay, we need this for today, but for, in 2-3 years time, we need this, which is how the industry previously worked. Now it's very much, we need this today. We don't really know what's coming. We can have a best estimate of what's coming. And again, technology will help manage that challenge that's faced by all of us.
Yeah, it's really important to have flexibility in and future proofing, right? And I think that there may be some cases where you're saying, look, I may not need a full 3 megawatts today, but I know I'm going to need that in a couple of years. And so let's deploy this solution and have that built-in future proofing that's already there.
Yeah, and I think impact on the industry as well. Like you touched on one point earlier, which I noted down, was people. And obviously I talk about it a lot because it's what I do, but trades is becoming a huge challenge in the industry. It's not an area I'm in, but the demand is increasing. I think it was Jensen who was from NVIDIA was telling everyone to become an electrician, wasn't he? Because the demand, you're going to need millions of them or whatever the number was in the next few years. But actually that's a big factor or a big benefit of this technology, because if you can reduce the amount of trades or skilled labor that's needed on site, it may mean that the people challenge can be managed as well as the power challenge.
You're exactly right. And this is a theme we hear from a lot of the customers that we're engaging with, especially on the campus side of things. So when we think about our medium voltage solutions, using conventional cables, we're starting to see folks build at the power levels that are now required, these massively complex duct banks. And you have a whole bunch of conduits and you have a whole bunch of cables that you have to populate those conduits with. And every one of those cables is generating heat. And so you have to think really carefully about the spacing and the backfill that you're filling the trench with and the cement that you're using in order to efficiently pull the heat out. And all that's labor intensive. And so you end up with an army of trades and really skilled folks that are in constant demand. And the inability to find those folks can slow projects down and really delay folks. And so when you have a technology like ours that can take that whole duct bank of dozens of cables and collapse it into just 2 or 3 cables that can deploy a whole lot faster, you can really solve some of these labor shortages issues and really accelerate projects going forward in a really meaningful way. I think the other thing that's emerged in some of our customer conversations around this is, speed's important, and speed is the thing that drives everything. But there's also a safety component. When you have job sites with thousands of people, the job site becomes a whole lot more complex. And so anything that you can do to speed up deployment, but also reduce the total number of folks who have to be on site every day and the total labor hours involved in deployment, you actually have a big safety benefit as well. And so we're obviously, safety is a core principle that is a bedrock of what we do, working with very high power, high voltage delivery systems. And so anytime a customer starts to say, hey, this is actually a safety benefit as well, we get really excited about that.
Yeah, it's a great point as well. It is a huge challenge for the industry to say the scale of these projects. And I also think that sometimes people forget that the power infrastructure is a huge talent drain as well. We're talking about building SMRs, major sort of microgrids, whatever it might be. That all requires the same labor skills as we do to build the data centers. So it's definitely going to be a challenge, and technology is the only solution we have for that. Before we go on to a couple of final questions, I just wanted to get your quick view on sort of power as a whole, really, utilize your knowledge in the industry. We've seen this week in the UK, they announced SMRs in Anglesey as, a potential sort of resource for an AI zone. What do you see for like the broader scale power challenge that we face? Is it going to be a bit of a mixture of every solution, or is there anything specifically you think that can really help manage the huge challenge that we have?
Yeah, I mean, it's always going to be a portfolio approach to lots of different technology options. I mean, that's the most resilient, most reliable, and most cost-effective solution. And so obviously we're spending a lot of time thinking about what are the controllable, dispatchable resources that you can build today in locations that are fit for size to data centers, as well as the broader market. So there's obviously a ton of interest in nuclear coming back. There's a lot of emphasis on geothermal that we're seeing. Wind and solar continue to be amazing resources that are low cost and fast to deploy. And so I think you're going to continue to see a lot of that interest. But at the end of the day, we need pure megawatts. And so it's going to be focusing on which of those can scale the fastest and get deployed the fastest and integrate at the right places in systems. And so I think you're going to continue to see a great diversity in the resources that we ultimately are deploying. I should also mention, of course, I think this is a really unique moment for the power system, because going back to the founding of Veir, right? Our focus was on decarbonization and the growth of electric power systems. And, it turns out growth in electric power systems is absolutely necessary for decarbonization, but it's also important for overall resiliency and economic growth and reindustrialization. And so the data center boom that we're seeing right now, if we can figure out how to solve these challenges and move fast enough, we're actually figuring out the same mechanisms and regulatory regimes and planning regimes that will then allow us to tackle all of those other growth challenges that are coming in the decades that are coming. And I think that this is a really special moment where we can figure out how to grow these systems so quickly, and the benefits will ultimately stretch way beyond just the ability to deploy data center infrastructure at unprecedented scale.
Yeah, we definitely can be part of the solution, can't we? And I think sometimes that's not communicated that well from an industry perspective. We can share stories like this, really, stories about the technology advancements that are coming into this industry that are going to help all of us, hopefully. And like you say, decarbonisation is a big factor in that. Before I let you go and go back to your busy day, no doubt, a couple of quick fire questions just to get your view on where the market's at. But if you could ask everyone in the industry to start or stop doing one thing, what would it be?
Yeah. Well, so we are in a period of unprecedented speed of change. And so I think that the big thing is this is a moment to be super open-minded and to really question the rules of thumb that have guided us historically, right? To solve this challenge at the speed and scale that it needs to be solved, we really need to start thinking really big. And we need to stop relying and really preferencing the way that things have always been done before. And I should say, we're seeing a lot of this, right? We're seeing a ton of interest in new solutions, but I think that this industry today is both highly collaborative and also really open to new ideas. We're never going to give up the requirement of reliability and safety, right? And I wouldn't ask anybody to do that. We got to prove that we can do all of this at the same level of reliability and safety this industry has always expected, but we can do that in new ways. And I think that's the most important advice I'd give folks today.
No, definitely. I think new ideas and new view, just a different viewpoint on things is really important. And that diversity of thought is something the industry lacked for a long time, and it's now there in abundance, and we're seeing the result of it, I think, across the industry. And final question, if you could give one piece of advice to anyone looking to work in the sector, what would it be?
Well, so I think it's focus on skating to where the puck's going to be, and understand from the outset that the speed of change is constant and only accelerating. I mean, I think where folks believe the architecture is going, where folks believe the power challenge is going, is fundamentally different today than even the conversations that we were just having 12 months ago. And, when you're going into a new field, and I've had the privilege of doing this a number of times in my career, there's a tendency to think, I need to understand how this industry works. And I'm going to go figure out what are the constant things that are always going to be true here. And, sometimes you can jump in, you can try to find your way to, okay, now I understand this is the way this industry works. Well, yes, that is exactly how this industry works today, but may not be the way this industry works in 12 months or 24 months from now. And we're seeing that with a lot of the financial arrangements and the ways that data center developments are happening and getting funded. We're seeing that in policy and regulatory change. We're seeing that in power and obviously, of course, liquid cooling, which is sort of the adjacent sister to power delivery solutions. It's all changing. And so you have to sort of be ready for this really fast journey where everything is constantly in flux. We're going to figure this out, and it's going to be amazing what we all achieve together.
Yeah, I think change and speed is what makes this industry so much fun to work in. I think it is that. Like, if you're comfortable being comfortable, it's probably not the right place for you. But if you like being uncomfortable, come and sit on the uncomfortable chair with us, and you'll have a great time.
I think that's exactly right.
Thanks for taking the time to speak with us. I know you're very busy, so we'll get this episode out quickly so your news will be very fresh in everyone's mind. But if they want to learn more about the recent news or Veir as a whole, where's the best place to either get in touch with yourself or where can they go online?
Yeah, of course. So you can always find us via our website, veir.com, veir.com. But of course, on LinkedIn as well. We're pretty active and would love to connect with folks and hear more about challenges folks are having or explore partnership opportunities.
Yeah, and I'll put the website and the press release in the show notes, so you can find it down there if you want to go and take a read. But thanks for your time, Tim. As I say, I appreciate you're very busy. Congratulations on the last 24 hours. I'm sure it'll be a fun next 24 hours and 24 months ahead. But we'll catch up again in the future. And as I say, thanks for taking the time to talk to us.
Really appreciate the opportunity.
That's it for this episode of the Inside Data Center podcast. Thanks for tuning in. This show is brought to you by DataX and Data Exec, the recruitment partners powering global talent across the data center and digital infrastructure world. If you enjoyed today's conversations, don't forget to follow, like, and subscribe. It really helps us grow the podcast community. Stay tuned for more stories, insights, and conversations with the people shaping the future of our industry.